Hi, everyone. My name is Ronnie Alstat. I'm the SVP of Strategy at Aqua Security. And today, I'm very glad to have the opportunity to speak to the Docker community about what security teams really want. So I've been working in the cybersecurity field for more than a decade. And one of the things that are apparent is that there is some sort of disconnect, oftentimes between the way things are viewed by security teams and the way that developers think security works. And I wanted to, dispel some of those misconceptions and also kind of highlight what we see as working in organizations where there's good collaboration between security and developers or DevOps. So a little bit about myself. I've been with Aqua since 2015, which is pretty much when it was formed, and more than 2 decades in the software industry, actually closer to three now. Um, and Aqua, if you don't know us, and I'm sure many of you do, we're a cloud-native security company. We sell an enterprise platform, but we also have a dedicated open source engineering team um, that maintains projects like Aqua Trivi, which is a universal scanner for vulnerabilities in open source and other security issues, and also some Kubernetes tools, and Tracy, which is an eBPF runtime protection software. So, um, and I'll touch on these tools later on in the talk. So, what are we going to cover today? Trying to understand, what it is that's new, what's changed since Docker, why are we even having this conversation, and why you should care, what security teams want, or rather what they should articulate that they want, what should you be doing in the meantime, and what should you ask of your security team in terms of articulating their needs better for you. So looking at software development today, and especially as regards Docker containers, cloud native applications, what's changed? What's new? Didn't developers always develop code, and didn't code always have some security issues? And we have a whole space in cybersecurity called application security that's there to address these issues. What's new? So I wanted to highlight three drivers that I see as really making things different. One is the very widespread use of open source. And from a security standpoint, that really means this constant inflation in known vulnerabilities or CVEs. So the number of CVEs is growing steadily. And that's not because software is becoming less secure, it's because it's more open. So it has more peering eyes, and people are trying to find vulnerabilities more than they used to, which results in finding more, of course. That's not a bad thing, it's a good thing. And second, of course, is just there is more software being used. So that's why we're seeing this increase in CVEs. And why is that? But why is that bad for security? It's bad for security because known vulnerabilities, unlike unknown vulnerabilities, can be exploited quite easily by attackers. And what we care about specifically is that time gap between the disclosure of a CVE and the time when it was actually patched or remediated or addressed in some other way by the user. And so when you have a known published vulnerability, usually there's also some short lag from that to having a publicly available exploit in the wild, and then it's like leaving your windows open. Basically, anyone can come in or your door open. So so that's why these are a concern. And of course, they are addressable, and there's a way to address them, and we'll talk about that. The second concern is this use of CI/CD and the acceleration in software development methodologies creates this constant change. And security traditionally worked under the assumption that there will be very discrete gates or points where they can test things thoroughly. And this no longer exists. So to deal with this constant change means you're dealing with a constant stream of new things you need to check. And both of these things are what's driving the shift left need in security. Basically, the need to start running tests and looking for things earlier and gaining visibility earlier in the software development lifecycle. Because if you wait until things are deployed in production, which was the way things used to be before all this happened, then you're dealing with a really impossibly large attack surface and constantly changing vulnerabilities and issues that you just can't chase fast enough. And the third is really infrastructure as code. So this ability of controlling programmatically how we deploy, what we deploy on, how networking behaves, how file access behaves, all of these things, again, this didn't used to be a case. You used to have very strict configuration management where you would have specific templates or specific types of servers that were hardened and controlled, and you could only deploy on them, and who and when and what gets deployed was very tightly controlled. And now, any developer can spin up some Kubernetes cluster on public cloud, or even a Docker file on a VM, and this already creates a different infrastructure environment. And infrastructure also has its own configuration issues that could leave the door open to attackers. And of course, combined with, for example, vulnerabilities in the application, or exposed secrets, or badly controlled network connections, all of these things can create this very toxic risk where attackers can easily not just penetrate, but also do harm. And so security teams are seeing all of that, and they're overwhelmed, right? And security teams, much like you would want your airline pilot to be, they tend to be control freaks, right? They want to control everything. And in this environment that I just described, you simply cannot control everything. That's an illusion. What you can do is reduce risk, and you can have better knowledge of what it is that you're doing, as opposed to just kind of waving your hands in the dark. So what do security teams ask of developers, or what should they ask of developers? So number one is transparency, right? We talked about shift left. We need to have this visibility into what's going on in the pipeline so that we're not surprised when things get deployed. And that's number one, right? And so, you don't want to find yourself with a production application running on an unsecured cloud instance or Kubernetes cluster, and you didn't even know it was coming. So that's number one. Number two is the ability to set boundaries. And I'm using the word guardrails here, because they're not so much gates as they are guardrails, meaning they don't necessarily stop things from happening, but they let you know that something is wrong and that it needs to be fixed or addressed in some shape or form. And these boundaries, in security we call them policies, right? So you have a policy, and the policy could say, for example, we do not want to see critical vulnerabilities in our production environment. Okay, so, and then again, the question is, how do you implement this? Because let's say that you're running an application, it was fine when it was deployed, but now there's a critical vulnerability that was discovered in your production environment. What are you going to do? Stop the application, shut everything down? What if you're an airline and that's your booking system? You can't. So, but there are other things security teams can do, and that's where we're talking about prioritization. So security teams expect, obviously, developers to remediate issues that they think are critical, but they have to provide you with a prioritized list, right? You can't just assume that things will just fix themselves and everybody's overwhelmed. You have to have priorities. Sometimes there's something that can be fixed, but it takes time because there are, let's say, multiple dependencies. Sometimes you just can't fix it. There's no fix for it. And then security teams have other measures they can take, for example, to mitigate risk, whether it's segmentation of the network or some, all sorts of runtime security or runtime protection capabilities, and monitoring and so forth. So these things should really be communicated to you, and on an ongoing basis, right? So basically, you would expect, the top 10 or top 20 or whatever it is you agree on, set of issues to be delivered to you, in a format you can consume and act on, and then tracked. And obviously, things like we don't want any vulnerabilities, or even we don't want any high risk vulnerabilities. That's not a policy. I mean, because it's not realistic to expect that in today's world. So what can you do? What should you be doing? One thing is really choose your images carefully. Um, use trusted or curated images. Docker official images are an example. So you at least know that they came from the right source and that they were scanned or given some sort of security examination before they were released out to the public. And in general, access to public registries should be limited. So if, let's say, you have an organization of 100 developers, you don't want all 100 developers going to Docker Hub or GitHub or other places and just downloading whatever, pulling whatever public images they can find. That's definitely a recipe for disaster. What you want to have a curated set of base images that are stored privately in a location that everybody can access, and that there's a small team of people who is qualified to place those images there, and then everybody else uses them. Another thing is to look at the age of your images. So obviously, old is bad because the older a piece of software is, the more known vulnerabilities it's likely to have. That probably already have exploits available out there, so it's highly exploitable. On the other hand, you don't necessarily want to use the newest one, because not enough people have looked at it, used it, tested it. So, usually there's like a one before last or two before last or some sort of policy that we recommend. And then obviously also, if you're using something that's not like super well known, not Alpine, not Nginx that are here, or things like BusyBox or MySQL, but things that are less popular images, and you're going and getting something from a public registry, look at the age of that project. If it's a few days old or even a few weeks old, unless you actually know where it came from, it's very likely that it's not safe to use. And look at recent activity, the number of contributors and so forth. If it's one or two contributors and it's new, wait with it. Of course, scanning, right? So we have Trivy, which is very widely used. There are other scanners as well. You can integrate Trivy everywhere, pretty much. It's available. You can use it to scan things in Kubernetes, on Docker desktop, in your CI/CD tools, in your SCMs. There's GitHub Actions and so on and so forth. It's very easy to integrate, and so there's really no excuse, and you can automate this very easily into your process, and just scan regularly for vulnerability, so at least you know if there's anything new that comes up. And don't forget to scan for secrets as well. It's not just CVEs. People often forget keys or passwords or certificates embedded in the code because it was put there because it's easier for testing, but then they forget to remove it before moving to production. Use a minimal OS, right? The bigger, the fatter the Linux distro you use, the more likely it is to have libraries, packages, areas that can be exploited that you're not necessarily using and you don't need. There are many other reasons why you want a minimal OS, but from a security standpoint, that's it. And also standardize on as few as possible, right? You don't want, again, when something happens, like for example, a vulnerability discovered, let's say in Ubuntu core, you want to know where you're using that, or maybe if you're not using it at all, you can very categorically say to your security teams, we're not using Ubuntu Core, so we're good. And of course, running containers as root. I mean, you probably heard this 1,000 times by now. It's a bad idea because it exposes you to higher risk in case there is some sort of breach, because it then allows an attacker to escalate privilege and get into the host and so forth. Another area is supply chain. I won't get deeply into that. It's a very broad area, but Trivy now also is able to generate SBOMs, software bill of materials. So basically, it gives you a manifest of everything that's inside your images or your applications. And the benefit of that is it's not something you need to do all the time, but it's a capability you want to have, because if, for example, the word comes down to say, hey, are we using this library that's vulnerable to, I don't know, Log4j? Then you can immediately, peer into what you're using and understand that. And in general, it's a good thing. Maybe first time you're using something, to look inside and see if there's anything that you're not familiar with. Another aspect is the security of the toolchain itself, where your CI/CD tools, your SCMs, your registry sometimes are not necessarily well governed and well protected when it comes to how they're managed. So, for example, too many people having admin rights, or too easily adding plugins or steps into your builds. And these can be and have been abused by attackers. And the CIS, the Center for Internet Security, came out with a benchmark for that. And together with Aqua, we developed an open source tool, Chainbench, that looks at that and gives you a rundown of kind of where you might need to improve your compliance in your tool chain. So that's another area to look at. And finally, infrastructure as code, misconfigurations, obviously very risky, because you can basically let people in to manage whatever it is you're running. So you want to scan your templates regularly, avoid those toxic combinations that I mentioned, and don't change your configurations frequently for no reason, right? So keep things as steady as you can, because you might break stuff you can't see yourself, right? Again, thinking of those toxic combinations, you might have changed something in your Terraform, for example, but at the same time, someone else changed how networking works, and now suddenly there's an exposure to the network. So not great. So what should you ask from your security team, right? How do you get to this better collaboration? So obviously, regular communication is at the heart of everything. Have a monthly call, weekly call, whatever, or appoint some sort of point person within your team to talk to security, and for them to have a point person to talk to your team. Ask them for realistic policies, right? So again, it's good to have aspirational policies like no high severity vulnerabilities. But if the reality is that you have 100 of them, for example, and that's not that rare, and to expect you to handle all of them immediately, and then of course anything that comes along, that's just unrealistic. So understand, get them to really focus on things that are doable and manageable, and have the right mitigation policies in place as well in case things cannot be remediated. Obviously, this comes with clear prioritization that's ongoing, right? Continuous. Automation. Everything I mentioned so far can easily be automated using open source tools, commercial tools. Very easy to automate. If they ask you for stuff that cannot be automated, it's very likely it's not going to happen. So you should educate them about that. And then, of course, have constant feedback. How are we doing? Are we improving? Are we getting worse? Right? I mean, all these things have to be continuously addressed. So I'll finish with some useful links. Trivy can do many of the things that I mentioned before: vulnerability scanning, scanning for secrets, scanning in multiple environments, including cloud now, IAC scanning. We integrated TFSec into Trivy, so that's there as well. Chainbench, that tool I mentioned that can look at your supply chain stack and tell you where you could improve. And finally, we have a YouTube channel, our open source YouTube channel, where there are many videos that explain how to do these tools, walkthroughs, and very useful stuff overall. And with that, I thank you, and I hope you enjoy the rest of the event.